Okay, this is your first of 3 periodic trend videos. The first one we're going to deal with is ionization energy. Now, ionization energy is, by definition, the energy required to remove an electron from an atom to form an ion. So, ion, okay, how much energy does it take to form that ion? Now, there are first ionization energies and second ionization energies, which refer to, the number of electrons that you're removing, but we're just going to deal with the first one, so we're just going to call it ionization energy. So if I have a neutral atom, how much energy does it take to remove an electron from that atom? Now, just a little refresher, okay, looking at our different columns, or what we call them families, okay, or groups, everything that is in the first column, this hydrogen family, okay, and everything all the way down, remember, those are going to form a positive 1 charge. Okay, everything in the beryllium family, right from here down, is going to be 2 plus. And we're going to skip over all the transition metals because the transition metals can form multiple ions. Yes, they do have ionization energies, but when it comes to what charges they form, this doesn't really play a part. So here I have boron, that's going to form a 3 plus charge. Okay, carbon for the extent of this class, we don't need to worry about it because the carbon family can gain or lose electrons depending on the situation. The nitrogen family can form a -3 charge, or does form a -3 charge. Oxygen family forms a -2 charge. The fluorine family, a -1 charge. And then the noble gases do not form charges because they are inert. They are happy already. They don't need to worry about forming bonds or forming ions. So, looking at these charges, we need to find out how much, just logically, what types of elements, okay? So let's go ahead and say these nonmetals and these metals, even though hydrogen is a nonmetal, okay? But because it forms a positive 1 charge, we're going to group it in with these guys. So we have group A and we have group B. So what do you think as far as which one of these elements or these groups of elements would require a lot of energy to remove an electron? Okay, and the answer is these nonmetals over here, okay, group B, okay, all these guys over here, they want electrons. That's why they form those negative charges. Okay, when they ionize, when they're either to gain or lose electrons. Well, in the nitrogen, oxygen, and fluorine family case, for most of them anyways, they are going to want to take electrons. So think about it. If somebody really wants something, it's going to take more energy for you to try to take something away from them. Okay, so think of it this way. These guys all here, they like electrons, and these guys here don't really like electrons that much. So here's their electrons. They don't really care for electrons. These guys over here really love the electrons. So just think of it this way. If you're a metal, you're probably going to have a fairly low ionization energy, meaning it doesn't take a lot of energy to remove an electron, versus if you're a non-metal, it's going to take more energy to remove an electron because you're actually wanting the electrons. Okay? Now, goes without saying, this noble gas family over here, okay, these guys have obscenely high ionization energies because they have their outer shell filled, they are happy. So they have all the electrons they want. So to remove their ionization, or to remove their electrons, would take a large amount of energy. But, we have non-metals usually are going to have higher ionization energies than metals, because metals want to get rid of the electrons and non-metals want to take their electrons or keep electrons, and in fact want more electrons. Okay, so the overall trend as far as how it's arranged on the periodic table, okay, ionization energy tends to increase as you go up a group and as you go across a period. Okay, the rows are periods. So your ionization energy should increase as you go up a column or and across a period. So, for example, I may ask you questions such as, which has a higher ionization energy, oxygen or carbon? Well, according to the trend, it's going to increase as you go from left to right, so oxygen would have a higher ionization energy than carbon. Okay, or if I said, which has a higher ionization energy, magnesium or calcium? Well, magnesium would have a higher ionization energy than calcium, even though both magnesium and calcium are both metals and they have relatively low ionization energies. Magnesium would still have a higher ionization energy. All right? So that's the trend as you go up a column, okay, or a group or a family, however you want to call it. And as you go across a period or across a row from left to right, it's going to increase the ionization energy.